It sounds impossible, but it's true. The water in your glass, that simple, familiar liquid, may be older than Earth itself. Every ocean wave, every drifting cloud, every drop of rain carries a story that began before the sun was born. This isn't hype. It's grounded in decades of observation and analysis from the European Southern Observatory, Cornell University, and NASA-supported teams using the Atacama Large Millimeter Array, ALMA, in Chile. In the young stellar system V883 Ori, astronomers have detected heavy water that contains deuterium, a heavier form of hydrogen, in amounts consistent with what we see in parts of our own solar system. The implication is astonishing. Much of Earth's water was forged in interstellar space more than 4.5 billion years ago, preserved as ice on dust grains, and carried inward during the birth of our sun and planets. Picture a vast, frigid cloud drifting through the Milky Way, so cold it's barely 10 degrees above absolute zero. In this darkness, oxygen atoms settle onto microscopic dust grains. Hydrogen atoms drift by, meet the oxygen, and water forms, not as liquid, but as ice, coating the grains in thin crystal shells. Those icy grains are the seeds of every ocean yet to come. They drift for ages, gathering in denser clumps, until gravity tightens its grip and the cloud begins to collapse. A pulse of light stirs at the center, the first heartbeat of a star, and the long journey of water toward worlds like ours truly begins. You're watching Wormhole to Cosmos, where the universe tells its own story. Here, in the frozen heart of interstellar clouds, the blueprint of our oceans was written, long before continents, before planets, before the sun. Long before our solar system formed, enormous molecular clouds filled the galaxy. Temperatures hovered near absolute zero. Starlight barely pierced the haze. Inside, dust grains floated like microscopic snow. Oxygen froze onto their surfaces, hydrogen found it and bonded. Water appeared as ice, coating nearly every grain. These grains became time capsules. Each icy mantle stored a chemical record of the early galaxy. Over millions of years, gravity compacted parts of the cloud until they collapsed. Deep inside, heat rose. A faint glow signaled a star about to be born. Today, telescopes like ALMA still see these nurseries, detecting not only water vapor, but also the telltale signatures of heavy water, H2O, D2O. Those isotopic fingerprints let astronomers trace the age and origin of water, following the same molecules from cloud to disk to comets, and eventually to planets. From this silent darkness, every ocean, every cloud, every storm began. Gravity accelerates the collapse. Gas and dust spin faster. Pressure climbs, and fusion ignites. A new star is born. Heat races outward. The icy mantles on dust grains sublimate, turning directly from solid to vapor, and the region floods with steam. Astronomers call this warm cocoon a hot Carino. Here, water becomes the second most abundant molecule after hydrogen, a reservoir so vast it would dwarf Earth's oceans by orders of magnitude. Farther from the star, the light fades, temperatures drop again. The bulk of the water refreezes on grains orbiting in the dark, a pristine archive of water's earliest history preserved against time and turmoil. Observations of systems like V883 Ori show heavy water fingerprints in these disks, consistent with interstellar ices. The implication is profound. The water now flowing through our oceans was inherited from the cloud that birthed the sun, not completely destroyed and remade, but carried through the chaos of star birth and preserved in ice. From frost to vapor, from silence to light, water survives creation itself. A wide, rotating protoplanetary disk encircles the young star, the workshop of worlds, and the vault of ancient water. Near the star, heat keeps water as vapor. Farther out, temperatures fall and water freezes again. The invisible frontier where vapor turns to ice is the snow line. As the star brightens, this line drifts outward, shaping which worlds form dry and which inherit ice. Beyond it, icy dust sticks more easily, growing into planetesimals, the guardians of water, bodies that will one day become comets, asteroids, and the cores of planets. ALMA's iconic image of HL Tau reveals concentric rings carved by newborn planets and zones where ices condense, the early architecture of a solar system, written in dust and water. From this disk, the blueprint of our planetary family unfolds. Beyond the snowline, icy rocks grow and collide. Some become comets, others water-rich asteroids. Gravity and the shifting orbits of giant planets scatter these bodies inward. They bombard the young Earth, releasing vapor and rain. For ages, storms rage, basins fill, oceans take form. For a long time, comets were the prime suspects for Earth's water. But their heavy water ratios often differ from our oceans. Meteorites from ancient carbon-rich asteroids, the carbonaceous chondrites, prove a closer match. The evidence points to planetesimals, asteroids, as the main couriers of Earth's water, with comets contributing variably. In the fire and chaos of impacts, our planet turned blue. Water is H2O, 2 hydrogens, 1 oxygen. But sometimes one hydrogen is heavier, deuterium, a hydrogen with an extra neutron. Water that contains it is heavy water, HDO or D2O. Deuterium was forged in the first seconds after the Big Bang. That makes the heavy-to-normal water ratio a molecular fingerprint. By comparing ratios in clouds, disks, comets, meteorites, and Earth, astronomers can trace whether water was inherited or remade. Disks like V883 Ori show heavy water abundances consistent with interstellar values, and Earth's oceans align with water locked in early asteroidal material. The conclusion: a substantial fraction of terrestrial water was inherited from pre-solar ice and has survived intact for 4.5 billion years. Heavy water is the universe remembering itself. Water is the great transformer. On early Earth, it sculpted continents, cooled volcanoes, and provided a cradle for the first organic chemistry. In the oceans, molecules began to link and twist, forming membranes, amino acids, and eventually cells. Without water's polarity, its unique ability to dissolve, bind, and carry, none of life's chemistry could have happened. And so, the same molecules that once froze to dust grains in space became the architects of life. Trace that story backward, and it leads from your bloodstream to ancient comets, from comets to cold molecular clouds, and from there to the first seconds after the Big Bang. In every living being, water is the thread that stitches us to the stars. The storm calmed, but water's journey never stopped. Sunlight warms the sea, vapor rises, air cools, clouds form, rain falls. Evaporation, condensation, precipitation, an endless circuit. Each drop is ancient. Some once froze on a comet, others flowed through dinosaurs or trees in vanished forests. Water never dies. It transforms, from vapor to liquid to ice, from ocean to glacier to cloud. Even beneath our feet, minerals in Earth's mantle hold water in crystal lattices, a hidden reservoir that rivals the oceans and helps drive Earth's tectonic heartbeat. Inside every living thing, those same molecules carry the cosmos forward. What began in interstellar frost now moves through roots and rivers, breath and blood, connecting Earth to the stars in an unbroken loop. In this dance, we don't just observe the universe, we participate in it. Water connects everything: comets and clouds, oceans and stars, you and me. It is the silent witness to every transformation in the cosmos. When you lift a glass of water, you're touching something eternal, a relic of cosmic memory. The same molecules that shaped continents, carved canyons, and carried life across eons once drifted in the cold between the stars. So tonight, as you watch rain fall or listen to waves break, remember, those sounds began in space. Each drop carries a story older than Earth itself. To everyone watching, thank you for journeying with us through the cosmic story of water. If this film moved you, please subscribe, give it a thumbs up, and share it with someone who loves the night sky. Tell us in the comments, what do you think is the most amazing journey water has taken? Your curiosity fuels everything we make. There's so much more ahead, fresh discoveries, new worlds, and deeper reasons to look up. Because when you watch, you don't just observe the universe, you become part of it. You're watching Wormhole to Cosmos. Remember, the universe is vast, mysterious, and full of wonders waiting to be explored. Stay curious, keep looking up, and until next time, keep your eyes on the stars.